Moving past negative belief structures, many of us wonder what we would do if all the programs we were raised with, poof, disappeared, leaving us free to figure out who and what we truly are without interruption from outside sources. This week, we have the opportunity to do just that by getting rid of those programs that have not served us. Join Jeff as he reveals ways in which the universe operates in a very similar fashion to the computer world. He explains where nefarious programs come from and how they have been manipulated into our belief structure. So, without further delay, thank you, Jeffrey.
Before I became a vibrational healer, I was in the computer industry. And my education is from the Ohio State University. I have a bachelor's degree in computer science in the College of Engineering. I co-opted, the way I paid my way through school, I co-opted by working at NCR in Dayton, Ohio. And I would work 6 months or 7, I forget exactly, it varied. But I'd work enough to pay my next quarter's tuition, then I would go back. And I did that for 7 years. I worked for NCR for 7 years. And I started out working in the tape library. And then I got promoted to be a computer operator. And then I got promoted to lead operator. And then I got promoted to shift manager. And then eventually I got promoted to the operations center manager, So I had the job of the man who hired me when I first started there. When I left, I was running the entire data center for NCR. Now, their corporate data center. NCR had multiple data centers, and it was a mainframe environment, okay? And now I've been in the business for over 30 years, and I've been very successful at it. I'm very grateful for it. It's taught me a lot. But one of the things that I realized is the computer world and the universe mirror each other in many, 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 many different ways. They're so similar, it is ridiculous. And I'm going to go through this diagram I have on the board, but as I was going through this tonight and putting it together, there's a lot of pieces I have left out. I could go much deeper than we're going to go tonight. But if you're a computer person, or or somebody who is a computer person watches this, they'll recognize the pieces that are missing. But this is enough to get the point across. Okay. So mainframe computers at NCR, that's what I started on. And then the PC came out. And NCR developed their own PC and started marketing it. And I began to look at that, and I delved into it, and I saw right away the potential for PCs and distributed computing, because up until that time, we had to use mainframe computers. And these mainframes would fill one machine it's bigger than any 2 or 3 or 4 story house you can imagine. It was incredible. We occupied the entire 5th floor of building 31 at NCR in Dayton, Ohio. And they were composed of multiple pieces. This the mainframe I worked on had a hardware component, which was called the CPU, which stands for Central Processing Unit. It had hard drives, it had memory, it had software that programmers would program. And when I first graduated, I started programming, but I was trained in COBOL, and that lasted less than 6 months. I absolutely hated programming. It was boring, just absolutely boring. I was used to the frenzied activity of the computer floor and mounting disks and mounting tapes and troubleshooting programs that had crashed and contacting software support analysts for help. I went back into operations, but I went back into communications, networking, because I saw, based upon the PC that had been released, that the real computer of the future was going to be the network. The network was the most important, because if you could not connect to whatever device you had, to whatever data source you had, your PC was useless. So I could see very clearly that the future in the computer business was going to be the networking side of the house. Let's get back to this. You have software, and that code is written in English, but then it has to be converted into a machine language. And then that machine language is loaded in the computer, and that's what gets executed. You have firmware. Firmware is the interface between various pieces of hardware. So you can add a piece of hardware to the computer, but there's a code in between that does the translation. Okay, so firmware is very important. You have the overall operating system. The overall operating system controls everything, is in control of how things function. It controls how jobs get ran, the priority of computing resources that are assigned to different various functions. You have data storage. Data storage back then was extremely important. Today it is. It's still important, but it's much easier. Back in the very beginning days of this, we had tapes, magnetic tapes, and you've seen those in movies, these big reels. We had thousands of these machines that just lined the floor. Discs, computer disk. When I first started, a computer disk was this wide, and they might have 7 or 8 platters to them. You'd have to lift those up and drop them in a drive and twist it and shut the lid and hope it spun up without crashing. Which today has been replaced by things like the cloud. Like the computers today can store everything in the cloud, and you don't have to have much on-site storage and so forth. That's what I mean, though. It's come a long way. And then this was a fascinating, very labor-intensive environment. And there's I forget what the law is called. There's a law in computers about doubling of capacity or doubling of ability every so many months. And that's, I can't remember, Oslo or something like that. And that's pretty much held true. I've looked back over the last 30 years, and that is pretty much held true. Every 16 months or so, 12 to 16 months, there's new technology available, more things, more capacity for less price. Okay, so, but then that migrated and began to morph in a different direction as chips got cheaper, storage got cheaper, and things began to go and convert from this environment into more of a server-based environment, where one server could do what a mainframe computer could do, 10 or 20 years before. Personal computers have proliferated. Everybody and their brothers got one, maybe 2 or 3. A lot of people have a desktop and a laptop. And then that's morphed even further into iPhones, iPads, and all the mobile devices. Everybody's got that as well, right? So I'm not running the numbers, but I would hazard a guess the computing power in this iPad is probably as much as it was when I was running mainframes for NCR. But my prediction that the network was the key has more than come true. We now call it the internet. And back in my day when I was working for large corporations, we would go in and put in dedicated telephone lines from point A to point B and build our own version of the internet on a private basis. Now that was back in the 80s. And then as the internet got rolled out, as different protocols got developed and communication got more sophisticated, the public was let in on the technology. So things like wireless technology, cellular technology, fiber optic tech, all that stuff, that's been around for years. We were using that in big corporations many, many years ago. It's just now that it's gotten so cost effective that it can be rolled out to the masses. And that's what has happened. So the configuration that won out is called Ethernet. That's a very specific technology. I often find that term ether, E-T-H-E-R-N-E-T, Ethernet, I find that not ironic, and not even coincidental. I think that's intentional. And you'll find out here in a moment what I'm going to talk about. But there were multiple technologies competing when this environment morphed, and there was IBM Token Ring. There was all kinds of stuff, different protocols used for communication between computers. But the one that ran or won out was Ethernet. And that's because it was just cost effective. And basically, Ethernet is one single cable in theory. There's, like I said, this is very simple. So you have a data server, you have multiple PCs plugged into that Ethernet cable. And when this PC wants to communicate or pass data or query this server to retrieve data, it sends a command down this line. The data server sees it, responds back, and provides the data. Now, in order for the data to arrive at the right place in the right way, in the right location, in the right time, you have an IP address. IP stands for Internet Protocol, and technically it's called TCP/IP, but we've shortened it to IP. But we all have IP addresses on our computers. So that way, this server knows this PC and returns the data to the right location, sends it down that pike. Now, extrapolate that out. This is very simple, basic stuff. You now have the internet itself. The internet is on a global basis. It works on a very hierarchical structure. There are levels of routers inside the internet. But basically, you have data centers, which is equivalent to this server. And these are Google, Facebook, Twitter, et cetera, and any smart company will have multiple data centers spread geographically, some, all over the place. You never put all your eggs in one basket. These data centers are connected into a POP, which stands for point of presence. And that point of presence is provided by some major carrier, AT&T, Sprint. I don't know who all's out there anymore. When I was in the business, MCI was a big player. But that POP then has routers in it. And those routers read these IP addresses. And then there's a server in here. It's called DNS, Domain Name Resolution Servers, DNS, Domain Name Services. And there's mass tables. So when you go to the Institute for Soul Evolution, that gets converted into a TCP/IP address. So that's what this does, and sorts through and then routes it to appropriate location, which then goes into a POP, point of presence, which then goes into your house where you're sitting. Okay, so you issue a command here, and it goes all the way through all these routers because things have to be converted to a proper communications protocol using the IP address and finding the IP address of the data center that you want to access. Okay, very, very rudimentary, that very simple explanation. It is mucho more detailed than that, I promise. And one of the gifts I have, and I used quite extensively in corporate America, was I had the ability, I could picture all of this. I would be dealing with engineers all around the world, and they would give me the details of their particular areas. And in meetings, I could lay out where the problems were. And they never thought of that before, but I could see the whole thing from beginning to end. I just had that gift of being able to assemble that picture in my head. And I used it, and I used it to great effect. So that's what's happened. We've morphed from mainframe computers through all these devices. We've expanded ourselves via networking. And then we took the networking to a whole nother level, to a stratospheric level, and made it sophisticated. So now we can sit here on a Zoom call and communicate with people on the other side of the world, just like it was nothing. We have instantaneous communication. And there's a lot of pieces and a lot of technology behind that. A lot. I mean, it's just mind-boggling. What's coming? Artificial intelligence. Now, I will be talking about this in great detail in the 28th event, but that's the next big surprise. I'm going to say surprise, but artificial intelligence. And that can be distributed amongst data centers, and then that can also be distributed into the network at different points through virtual private networking, virtual LAN kind of situations and so forth. You can hide AI in a lot of different places. All right, that's the world of computers. It's ones and zeros. At the end of the day, it's all ones and zeros. Either it's on or it's off. And then 8 bits of those make up a word, make up a character, and then those characters, more of those make up a word, and so forth and so on and so forth. How does that compare to the universe? Well, here's me, and this is the way I do my job. This is the way I work with clients. And I have a body-mind-field complex. And in this body-mind-field complex, I have hardware, this body. I have software, the electricity, everything that's running my mind, the autonomic nervous system, the parasympathetic nervous system, all those different parts. I've got firmware that tells me how to interface with the world. I have an operating system, my genetics, my DNA, my code. I have data storage, which is the cells of my body. My cells can literally store data and information. My brain does too, but the data and information that gets stored at the cellular level can be shock or panic or trauma or memories or all kinds of stuff. Okay. So I have many of these pieces. I have a body-mind-field complex, and it processes like a computer does. Now, the thing about a computer is it looks like it's doing multiple, like it's multitasking. But if it has one CPU, it's doing one instruction at a time. That's why you hit Word, you hit Excel, you open a browser, all that kind of stuff. And the more things you open or initiate an opening of, that one CPU has to sit there and process that information and bring up the data and do what you told it to do. It's only doing one thing at a time. Our body-mind-field complex is just like that. A little more sophisticated, but it has an equivalent of a CPU where it processes information. So the field has its own operating system. I've already gone over its hardware, software, data storage, and communications. My IP address, the equivalent of what this PC has, is my baseline vibratory frequency. If I can tune into someone's baseline vibratory frequency, I can find them anywhere in the world. Okay. This is the equivalent of a network. So I go up to the creator connects me back down to who I need to talk to. And, at the end of this session, we'll be doing a clearing, and we'll be doing multiples of those. So that the creator will be routing my data that I'm putting into the cloud back down to everybody. So it's similar to cloud computing. I also have AI, artificial intelligence, or the equivalent of. It's not really artificial, it's the real intelligence. And so do you. What I'm saying about myself applies to everybody on this call. But your AI is composed of sovereignty, your ability to control the outcome of your life, agency, your ability to do things and execute and acquire and build, and most important is consciousness. And that's one of the things that they will never, ever be able to duplicate here. Now, they're going to try, don't get me wrong. I know they're going to try, but they will never be able to achieve that because consciousness belongs to spiritual beings. It does not belong to machines. And they'll take somebody's essence and being and their thoughts and their history and load it into a machine and call it consciousness, but it will never be there. So that's why AI is nothing to fear. It's merely a tool that we can use to create faster, build better, achieve more. Of course, there'll be people who try to use it for nefarious means or whatever, but I'm not worried about that because they will never match a human who is having a spiritual being is having a human experience, they'll never match it. They'll never come close to it. It might beat us. You know, like IBM has worked for years on their chess computer, and it's played the top masters in the world, and recently it's finally beat them. But that's just computing power, more lines of code. It's not that computer was using its sovereignty, agency, or consciousness. Wasn't. So, all right, so that's how they mirror each other. Network, the equivalent of a PC. Now, what are some of the common problems? Because if the physical environment mirror each other, there's got to be a mirror of some of the common issues. Well, hacking. In the computer world, you can steal. I could literally write a piece of code, get it on your machine, and I can steal your CPU. And so if you leave your machine up and somebody's got access to it, they can come in there and dump a program on it that from midnight until 4 a.m., it acts like a server. And then this person can develop more code on it, can do all kinds of stuff on it you're not aware of or have no idea it's going on because the machine's been hacked. But they can steal CPU, they can steal resources, they can steal your information. There are things such as keyloggers, where every time you type in your password, it logs that and then uploads it to some central server. And then that hits the internet. Lo and behold, next thing you know, your credit card is messed up because somebody's got your data. That was all done through hacking. There's spoofing. There is a process in the internet where you spoof IP addresses. And spoofing means basically, instead of showing you my IP address, it gives you a bogus IP address. Or what happens is there are multiple houses out here. Each one is supposed to have an IP address, but the carrier doesn't have enough to go around. So they'll present an address to the internet and they'll do the conversion back to the addresses for the individual houses. So that's spoofing. You can do that in somebody's field. You can use what's called etheric duplicates. Somebody, if they really wanted to do something to you, they would copy your field, put it out here in the universe somewhere and torture it or do terrible things to it, and you would feel it because your baseline vibratory matches. But they're spoofing you and they're attacking you over here. So if you don't know to look for that, you can check this person and go, are they under attack? No. Are they under assault? No. Are they under this? No. It doesn't matter. They're not. But their duplicate is. There's partitions, hiding data. And this is on a hard drive. All right. So I could go in and partition a hard drive and then put a whole nother operating system out there. And then when you're not around, I could come in and boot up that other operating system and run your Mac as a PC or vice versa. There's ways to partition data where the data is hidden. You can't get at it. Information. Okay. There's bots. Now these are permeating the internet like crazy. And a bot is basically a computer program that's charged with doing something, a response. If it sees a certain condition, it'll respond to it. Elon Musk has released a lot of Twitter files about all the bots that they discovered on Twitter. You think you're talking to a person, you're actually talking to a bot. Again, that's expert systems miniaturized down to the internet environment. And viruses. And we all know about viruses. That's how Bill Gates got his business going. He would, it's come out. I met Bill Gates several times, but it's come out that, you know, he had a team of crack scientists that were creating these viruses. And guess what? He also created the control mechanisms for it, right? But somehow they were always one step behind. So a virus would hit, or a virus would be coming, and we would go out and go and change the machine code on millions of PCs around the world, and only lost a segment of them. I mean, it was a nightmare, but that he was in the virus business, creating it and fixing it. Kind of sounds like some of the stuff he's up to today. Viruses. Okay, so that's the similarities. The universe operates in a very similar fashion to the computer world. Now, I'll never forget the day I had this epiphany. I was sitting in a workshop with Fred, and he was trying to sell us on the apprentice program, and I wanted to go so bad I could taste it, but I kept talking myself out of it. And I was sitting there thinking, how the hell am I going to tell my family that I'm leaving corporate America and everything I've worked for all these years to go do healing work? How will that fly? I was trying to talk myself out of it. And then he said something about baseline vibratory frequency. And it hit me right then. It's like, oh my God, that's the IP address. And then it was like, boom, 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 boom. Like it just got laid out right in front of my eyes. You know, like I could see the big picture down here. I could see the big picture right here. And then I thought, that's it. I got to go study this stuff, because it's taken computers and data and information to a whole nother level. I mean, to a level that's not even achievable, right? This all requires hardware, software, people, coding, rules, structure. This is who we are. This is who we are. This takes me signing on to the network here in the house, putting an IP address or putting in some kind of a network name, all this hardware. I can sit here and access anything in the world, but I don't need that. I can sit here right now and access anything in the world and beyond. You can too. You can too. Your spirit having a human experience, and you agreed to the rules of the matrix of this earth, which means gravity works. You have to eat food. You need to drive a car to go from point A to point B, or take a bullet train if you're in a country that's so lucky to have that kind of thing. You have to physically put your shoes on, whatever. I mean, there's certain rules you agreed to, but there's certain things you didn't give up. And that is your ability to move energy into matter. Your ability for vibrating ether into some kind of form. You didn't give that up. You didn't give that up. All right. Man, I have yammered. Okay. I get excited when I talk about computers. All right. So tonight, what we're going to do is go after programs. So over here, a programmer would write code. He would sit down and, like on COBOL, now the only language I'm trained in is COBOL. I've not gone back and taken any of the newer languages like C or C++ or Raspberry or anything like that. So COBOL is the old-fashioned way. You do if-then statements. If something else, if this happens, then do this. If then. It's a series of if-then statements. But people are writing new programs for PCs and the servers, and even the routers are computers. These are computers with just different functionality, but they all have programs, and a program has a beginning, has an end. So when you write a program, you start it off and you have an objective for what that program is to do. Like when I was at NCR, I wrote a lot of stuff for accounting and business management. And so you always know what the end result is, your use case. And so what gets done over here in this side of the house is programs are being used by the powers that be, by evil, by the dark side, by the people who want us spiritual folks to be suppressed, stomped down, stopped in our tracks. They're developing programs and ways of being, and then putting those in our field to stop us from moving forward. And we're going to go after those tonight. Okay. All right. So I'm going to go into a little bit more detail than I normally do with the protocol, simply because of what we're clearing, you need to know, and it'll also make a little more sense as you process this out. The timing of this is absolutely perfect because we have a 2-week break. Yeah, we have a 2-week break, so you're going to need all 2 weeks. All right, so the protocol I put together tonight is called programs. We're going to clear specific forms of forces, programmed forces. These are specific forms of programmed forces that are designed to cause dysfunction at nearly any level of functioning and mood or emotional state or condition. So this is literally a program that's running in your field designed to booger up your emotions. Okay. Remember, everything I'm talking about tonight is intentional. It's either evoked, convoked, invoked, and that means placed in your field. Now, how does it get there? Well, hell, if I can do it, if I can access you, we know the powers that be can access you, just like any computer on this network. As long as you know their baseline vibratory frequency, as long as you know their IP address, you can get at it. All right. Specific forms of forces. They are programmed for a specific form of interface and dysfunction. They do confirm to be sent to the individual through some other form of evoked process. They do not confirm to have any form of matter associated with them. They're primarily information and instruction. So, and that's exactly what I was talking about earlier. All this, whether it be hardware, software, firmware, or operating system, is information and instruction. Information and instruction. And in this case, this is information and instruction for you to malfunction. Okay.